Hello everyone, today is August 17, 2020, and today's lesson is going to be about solving absolute value equations. So there's a few things you need to know before we actually do some examples. When you're solving absolute value equations, first of all, you need to check, is the absolute value isolated? And if it's not, you need to isolate the absolute value expression by using reverse order of operations. And once you isolate it, there's either one scenario or another scenario. The first scenario is if the absolute value expression equals a negative. If your absolute value expression, so here's a little example here where I have absolute value with an expression inside and it equals a negative number, then that's going to be no solution. And the reason for that is an absolute value expression, remember, that's a distance from zero. A distance is always going to be positive. So an absolute value is always positive. So if it equals a negative, well, that doesn't make sense. A positive cannot equal a negative. So that's why we get no solution when an absolute value expression equals a negative number. But if the absolute value expression equals a positive number, then you actually have to solve it. We do have a reasonable solution. So what you're going to do is you're going to create two equations. One of the equations is going to equal a positive number, and the other equation is going to equal a negative number. Oh, I'm sorry, I went ahead. The equations you create do not have the absolute value symbol. So you're going to remove the absolute value symbol and then make one equation equal a positive number and one equation equal a negative number, and then you're going to solve both equations. So just to recap, isolate the absolute value, check to see if it's positive or negative. If it equals a negative, it's no solution. If it equals a positive, you need to do two equations, one without the absolute value where it equals a positive, another without the absolute value where it equals a negative, and solve both equations. Okay, so here we have our first example. Very simple. The absolute value of A equals 6. The absolute value is isolated. There's nothing multiplied in front. There's nothing added to the back. It's just absolute value. It equals a positive number, so we can make two equations. So we remove the absolute value and we say A equals 6 or A equals negative 6. And those are my two solutions. So now we write those in a solution set. So this brace means the set that contains negative 6 and positive 6. So there is our solution set, the set that contains negative 6 and positive 6. Okay, here's our second example. Our second example is 2 times the absolute value of 3y minus 9 equals, minus 12 equals 6. Let me repeat that. 2 times the absolute value of 3y minus 9 minus 12 equals 6. So let's go ahead and isolate this absolute value, because notice we're multiplying by 2 and we're subtracting 12 on the same side as the absolute value. So we need to use reverse order of operations and isolate it. So first we're going to add 12 to both sides, eliminating the 12, and we get 2 absolute value of 3y minus 9 equals 18. And now we're going to divide by 2 on both sides, reducing the 2, and we get the absolute value of 3y minus 9 equals 9. So now my absolute value expression is isolated and it equals a positive number. If it equals a positive number, we need two equations. We need to remove the absolute value and say 3y minus 9, see, no more absolute value, equals positive 9, or 3y minus 9 equals negative 9. And then we solve. So we're going to add 9 to both sides here, eliminating the 9's. And we get 3y equals 18. We're going to divide by 3 on both sides, reducing the 3's. And we get y equals 6 for our first solution. Now on the other equation, we're going to add 9 to both sides, eliminating the 9, and we get 3y equals negative 9 plus 9. Well, that's going to be 0. And then you can still divide by 3, but when you divide by 3, you're still going to get y equals 0. So you get two solutions, 6 and 0. And we're going to put that in our solution set, the set that contains 0 and 6. And there is our solution set. Okay, so here we have our last example. Our last example is -3 times the absolute value of 3t minus 2 minus 12 equals -6. So, notice the absolute value is not isolated. We're multiplying by -3 and we're subtracting 12. So we need to use reverse order of operations to isolate it. So first we're going to do addition and subtraction by adding 12 to both sides. That eliminates the 12. We get -3 times the absolute value of 3t minus 2 equals 6. And now we need to get rid of this times the -3. So we're going to divide both sides by -3. That's going to reduce our 3's. And we get the absolute value of 3t minus 2 equals a -2. So now my absolute value is isolated. However, it equals a negative number. And remember, the absolute value is a positive number. It cannot equal a negative. If it equals a negative, that doesn't make sense. That's a false statement. So this is no solution. And the way we write no solution in set notation is by writing a circle with a slash through it. This right here, if you want to label it in your notes, is called the empty set. So this is the set that doesn't contain anything at all. So this is the empty set, and that would be our way to represent no solution. Okay, well, I hope you enjoyed today's lesson. If you have any questions, please send me a message via Schoology, or you can send me a text. Have a great day, everyone.